stage is yours. Please start.
Hello everyone. I actually started my career in cybersecurity more than 10 years ago as a junior malware analyst. I have no idea about what is reverse engineering, what is the malware. So I've seen malware on my computer, but I have no idea how it works. I was curious about analyzing the actual behavior of techniques, of deep technical concept of a malware, what actually could done with my computer. And that's how I got in Kaspersky as a junior malware analyst. And in the 3 months I proved that I'm able to did my job at a very high level. So they actually get me in I become like malware analyst, and then I become senior malware analyst, and in a few years I was one of those guys who was in the top detecting everything in like few bytes. So it's kind of state of art for me. When you have a piece of malware, you're able to dissect it, and you see like, I don't know, 20 bytes that actually describe that particular malware or some of its characteristics, and you're able to actually find those like 20 or 30 bytes of the algorithm, main algorithm of the malware, and actually detect it. I have a lot of arguing with my colleagues who bring me some like things like, oh, you have a false positive. I said, no, it's not, because those 30 bytes or 20 bytes completely describe the algorithm of the malware I'm supposed to detect. And it was a quite fun time. Since that, 10 years passed. I learned how to pen test the regular IT systems. I learned the techniques used by cyber criminals to intrude those systems. And 5 or 6 years ago, I switched to industrial control system to learn something new, because I thought I learned everything in IT. That's why I switched to ICS. And I found a lot of hard questions about the ICS and the cybersecurity in ICS. So how much of you actually aware of ICS? Just like raise your hand. Okay, so all of you know about like what the SCADA, PLC, DCS, and all this stuff. How much of you are aware of cybersecurity of ICS? Like, oh wow, okay. So you know about like protocol dissectors, about like rules and all that stuff. Okay, and this lecture actually will be about penetration testing into ICS, and not like general penetration testing, because from one side the ICS is just the same IT stuff, but it used to control some like physical things. But like on the other hand, the same Windows computers, the same Java runtime, the same problems, even more, because they implemented a lot of IT new features but forgot to implement a lot of new IT security features, and because of like maintenance strategy is for 10 years, they are not able, people in place, people in field are not able to maintain all that cybersecurity problems. When the new vulnerabilities have discovered, they have to do a lot of work before they can implement the patch into the production system. They have to test it, everything. And today's lecture about like 3 major aspects of ICS penetration testings. So in my opinion, those 3 are interconnections of elements. So you have to understand how elements of ICS are interconnected and how they actually involved in the technological process. Like which part actually means what. The second is actually gets from the first. It's a domino principle. When you actually hit one element, make it have a state it's not supposed to have, all other elements will react in some improper way and actually broke all the ICS, all the technological process. And the third thing is, I probably think you'll say, oh, there's a lot of self-stabilizing systems that will actually understood that something goes wrong and do stabilization algorithm and I don't know, shut down the power plant just because some sensor is broken. But there's a strategy how to destabilize those systems to make it think everything is fine when everything is bad, or otherwise in a way it will like destruct itself. Let me start from the interconnections and the elements. So that thing I'm pretty sure you know that the whole technological process, like it consists of all the elements and the logic on top of it that actually control all the actuators and all that stuff. From a penetration testing perspective, the first thing you have to do to understand the technological process of some unknown factory or, I don't know, unknown power plant, you have to, if you're lucky, look at the graphical schemes like at HMI to understand where actually elements are, what the role of those elements. And the second step is to intercept the traffic, and then you have like most tough task to match that graphical interpretation of a process with actually the network traffic, because in the network traffic you have a lot of like IP addresses, you have a lot of tags, you have to match them so you understood the logic, the flow, where the values like goes up and goes down, when the valve is open and closed, like, and what actually happening. And at the last step in the penetration testing, you're actually doing kind of exercise. You're doing like changing something in the traffic, some parameter or some value, or maybe command the controller to do something, and look at the HMI, like what's happening, to understand actually what's the consequence of what you're doing. That's how you analyze the system if it was a black box. Do you know the black box concept? Okay, that's nice. So here's a huge simple HMI, and you definitely can see the valves, pumps, sensors. Can you see it? Valves, sensors, pumps? Okay, that's nice. Here, can you identify the same elements? Have you any idea about what this technological process represent? Like, what was technological process represented by HMI, this particular? Any idea? Heating the water, but what for?
Power generation. Steam?
Yes, yes. Nice answer. So it's actually the power generation, steam generation for heating the cold Russian people out there. It's some picture from internet, but I'm like happy that you understood at least something from that HMI, because most of the people could not get any idea like something from something. Okay, what's this? Give me an answer. What? Yeah, but what? Liquid gas, maybe. But why do we have that start tank? What is this? And heating exchanger, and like.
Raffinery. It's oil.
Think more about, like, I'm for sure give you kind of some help for free. I'm the guy from Russia, and in Russia we have like very cold weather, especially in Siberia. So the Siberia is a huge area over Russia, and we have a lot of like resources in the Siberia that we actually dig. Quite close, but actually it's not the distillation, it's the gas oil discharge terminal. So just imagine the Siberia, the very cold forest, beers, there's a huge pipe with oil filling the tanks on the rail, and those tanks gets to the discharge terminal. And what's actually happened with oil in those cisterns? It's actually freezing. So the only way to get oil out of those rail cisterns from top is to get it warm, and then you can actually took the warmed oil out and put it in the storage tank. So that's something you have to think about when you think about Middle East. You have to take into account the weather, the condition, all that. Like talking about Russia, you have to the same, taking into account the condition, and the engineers who actually develop those non-trivial industrial control system. They have to every piece of that actually solving some puzzle, solving some doing actually some work, not just for free here. Have you can you propose some attack on that kind of system? Like what could be done in terms of penetration testing? Like if you have access to the internal network and you see all the controllers that actually control all those valves and pumps and the heats and everything, like
Stop heating.
Stop heating, so it will
Valves.
open valves, but if you open them
Too much, I think, that will destroy this process.
not that much, but if you actually stop heating, the pumps will actually burn because they cannot pump the cold oil because it's like too crude. Okay, have you experience with power grids?
It is faculty, yes.
Oh, that's nice. That's nice. It was a joke. Okay, so you know about like circuit breakers, right? Like the substation. It consists of elements like circuit breaker, ground breaker, all this. Do you know the high voltage bay relay?
Actually, I would assume that all of participants have knowledge about electrical, engineering, because we are on the faculty of electrical.
Yes. But people just looking at me like, what? Okay, so I have decent experience in penetration testing into the power systems, power grids, and analyze different subset, different architecture of power grids. Actually, in all of those different architecture system setup, there's still the same elements like a circuit breaker. And to control the circuit breaker, you have to control the high voltage bay relay. Can you tell me any product that you know, just name any circuit high voltage bay relay that you I don't know. For like Siemens, do you know? Oh yeah, no. Siemens, and you just state the name of the product. No. Ciprotec. And for ABB? Yes. So there's a lot of vendors actually producing the same equipment, kind of different equipment, but is there any standard that actually describe how the power management should be accomplished in terms of electrical engineering things? Do you know any standard?
I see 61850.
Yes. Wow, that's actually cool. So, and that standard actually prescribed different types of protocols like Goose, MMS, samplet values, and other. And for sure, because there's a lot of companies involved in that business and producing the equipment, they have a lot of proprietary protocols that allow us to upload the firmware to the controller, like changing the memory, getting the memory from the controller. And doing a penetration testing, you're actually dealing with the traffic, with the network traffic, and you have to be able to dissect the all those like IEC 61850 protocols. Thankfully, the open source community actually developed a lot of dissectors and for Wireshark, and you can like reuse it for free, just for free if you're like not a business. If you're a business, you have to pay. But there's a lot of other protocols that are not dissected at the moment, and like they are dissected by some enthusiast or some security companies, but there's no dissectors for those protocols in the public. So doing the penetration testing on the other side, cybersecurity defense practice, you have to understand that actually someone tried to, I don't know, rewrite the firmware of a super attack. 4 years ago, we're actually running the CTF. Have you played the CTF ever? Capture the flag competition? Okay, there's like a capture the flag kind of file-based, there's like Jeopardy, and there's like real capture the flag when you sitting in front of a kind of ISS equipment and you have only 2 days to hack it in any way you wish. And we actually managed to organize that kind of competition, and we run the file-based competition on the web to choose 4 top teams from all over the globe to ask them to get to our conference and participate in the CTF with hardware and all those hard tasks. And we actually managed to get 4 teams. We built a stand. Most of the like Siemens and ABBs. There was a Hirschman gateways and switches. There was like a Cisco. We built more or less secure because we have to have some room for fun still. So we're not like completely secured, but like leave some room for the players. The top goal was to burn the power line to cause the short circuit. So like a model of a power line will burn with a lot of snaps out there. And we have 2 days for 10 hours, like first day 10 hours and next day 10 hours of access. And we thought like, okay, hopefully at least one team will actually burn the power line at the end of a second day. It would be nice because like everyone see that the hackers who have not aware of a setup of that thing, who have no access except like public access, or I mean some limited access to that stand, being able to actually manage to find the exploit and actually pin test that stand. I'll ask you a question. How do you think how much time the first team was spent before they burned power line?
4 hours.
4 hours. Actually, you get in the point, like straight to the point. They 4 hours, and we see like the ring bell, like blah, 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 and a lot of snaps out there. It was like, oh gosh. So we have 2 days, and those guys just like complete in the first half. It was amazing experience for the first time. And actually, what we learned from that, there was a people for like first 4 hours. There was energy engineers. So they actually have all the software to access the equipment, to reprogram it, and so on. And the second team was just like regular pen tester, and they actually look for a traffic. They were able to dissect it, to analyze what actually first team did, and actually reproduce the same, and goes even more. After the event, we have one high voltage by relay goes like denial of service completely. We give it to the vendor saying like, this is not working. It cost like $50,000 and it's not working, so fix it. The vendor spent 3 months trying to figure out what's actually happening, and they have no idea why it's not working. It's like even not turning on. After like spending 4 months, they said, oh, okay, we figure out. Somehow, the memory where all the low-level connectors or interfaces, low-level interfaces, was written. Like there's a small memory, read-only memory, with a table. In the table, describe all the interface devices like in a controller, and it was somehow corrupted by a network packet. And we actually find out the traffic, analyze it, and submit the CVE for that vendor, and got the like CVE for denial of service condition, like probably remote execution. It was something that happened just like, you know, out of your control. So can you tell me what's the function code in the protocol of most of industrial control systems? Like there's many protocols, and most of them have a function code. So what is a function code or service? Have you any idea? So there's like a PLC, and you can command the PLC some function code or service. So you never heard about the service and function code. So you never opened the Wireshark, right? To look at the traffic. And this is the tough task, because when you start to look at the traffic between your engineering computer and the PLC, you see a lot of strange and like things that not look like what you actually program in a step or in a ladder. The function code and the service are quite simple concept. They allows you to read single value, read multiple values, read range of values, or otherwise write single value or write a list of values or set the command. And for sure the PLC have some assigned function codes for stop, stop, restart, cold restart, warm restart, and so on and so forth. So the function codes actually the codes that control the behavior of PLC. On the PLC side, there's a code that actually gets those integers interpreted in the right way and actually performs some function. There's like variables for sure. I'm pretty sure you know that concept. There's values that you can get from a PLC or other low-level devices, and the types in which those data could be structured. It could be like a single command, single value. It could be a list of commands and a list of values. It could be folded structure. And have you ever read or seen the CIP protocol? Oh yeah, so you are aware of folded structures, all those trees. Yes, it's object, but from perspective when you dissect it, for me personally, it's just like a lot of folded objects, objects inside the objects inside the objects. So when you look at those like hard organized data, you have to understand actually it's not just the data inside the data inside the data, it's object that represents some state, that have some attributes and parameters, that have actually not the values inside, but other objects that represent some other data, and so on and so forth. And that's the representation from Wireshark. And the only way to understand what's actually happening is to having some lab or some small process that you can actually analyze. And when you like turn on, turn off, or change the parameter, you'll see the difference in the values. You see in the like where the type of the parameter sent. Is it kind of discrete value, or if it's something, I don't know, value of linear function, or kind of. For the power grids, there's, and for many others, but for power grids for sure, there's a kind of notation of how they name all those long structures. And here you can see some string you can actually find in the traffic or in the project. And it's like relay, XCBR, ST, log, ST, val. Is there someone who understood this thing like natively? Oh well, you're cool. The idea is that you go to the standard and actually read a lot, and then you go to some forum or other place where people discussing something, and you're actually reading there and trying to figure out what each of those part meaning to being able to control it. For penetration testing, this knowledge is very important because you have a lot of such parameters and data passing here and there, and to understand how it actually mapping on the physical model. You have to understand what means each and every, because in energy, you not just like having like on and off. You have a lot of those function codes that you used to query for state of a lock or state of a circuit breaker or state of a like selected function, or to select a function, or to perform selected function, or to cancel it. And there is like a quite simple notation. Q, QS, QSG is for breaker, switch, and ground breaker. Like the main idea that I told to people who actually hear this thing is the brief concept of that part is you have to get into the basics. You have to took a book of how the power grid is actually designed and understand the design itself of a power grid to understand what actually functions were performed by humans and how those functions now performed by computers. Only this way, because nothing changed. The only humans were changed by computers. That's the only difference. And this for classic power grids. For smart grids, their things are much complicated. So I'm pretty sure you seen the kind of domino principle in a real life. When the tree falls, it actually cuts the power lines. It actually fall on the car, and there's I don't know some fire, and so that kind of chain of cause and reason things that are actually happening. And if you thoughtfully manipulate the technological process, you will actually find a lot of those chains to trigger. And once triggered, it will gets like further and further destructing the process itself. And the power grid, because that's my I don't know. I have a lot of examples for it. That's why I choose the power grid to tell you about. So, do you know like before reading the text, do you know what is the main goal of the automation system for power grid? So the main role of all the system. Okay, there's actually written is to keeping the balance, because all the power produced have to be utilized. So there's no like power in the grid without like being used or something. And once you have a condition where the power grid is like consumption and production is imbalanced, you have a kind of condition that cause some bad effects. Can you name those effects for like all the parties involved in the power generation and consumption. Like imagine you have I don't know, blackout. Wow, that's nice. What else? Blackout. Overloading. That's nice. And what actually will go after overloading?
Downside, maybe hertz. What the hertz is frequency.
Yeah, sure.
Can impact the frequency and usability of this.
That's true. Somewhere in the middle, some equipment will burn because of like overload. Maybe some threats for power production side. What? Yes, actually, that could happen. I'm pretty sure. Are you participating in the like cybersecurity conferences? Like, okay. So in Moscow we have annual conference called Positive Hacking Days, and the organizers of that conference every year they bring some new equipment, new architecture of some cybersecurity system. Or control system, and allows participants to test their penetration testing skills on their system to try to hack it and get a prize if they're able to hack it like first and or in some nice fashion. So a few years ago there was a kind of setup with hydroelectric power generation station, there was a distribution substation, there was a kind of city, and there was some mystic power, like nuclear power plant, but there was like no nuclear there. It was just on the paper, but it was still somewhere in the system. But hydroelectric power system was kind of built in miniature. So there was like a huge bath filled with all those, like this landscape is actually a huge bath. It's like that big. It's like, and there was like all those small houses, and there was like a huge amount of water. There was a pump that pumped that water. There was a miniature of hydroelectric station that actually produced the energy by running all that water. So everything was done close to very real, and was equipment actually controlling all that process. And there was some, I don't know, student at when you complete the school, right? And when you at the school, scholar. Graduate. Okay. So there was some kind of like smart graduate guy who thought, oh well, what will happen if I like control the circuit breakers on the distribution substation and disable the oh, it's not manufacturing, it's like power generation. Like, what if I like just like turn them off? And he just decided to turn off the nuclear power plant on the right side. So you can see there's a substation that actually get two power generation sources, and there's like a transmission and the one consumer of all that power. So he actually decided to disconnect the generation source at the right. And then he decided to disconnect the consumers. So what actually happened if you go to some forums or a library and read about the hydropower generation system, how it actually built, and what function out there, and what is actually the fault situation prescribed for those systems in case when he actually when the graduate guy disable connection at the transmission substation, it cut the power source from a power plant. The city start consume electricity, and the hydroelectric power station have to run on the 100% of power to fulfill the balance, like to fill the grid with energy, because there is no other sources. And once he actually once he actually cut the consumers, so the power plant, well, what actually choice they have? If you are a power plant and you produce like tons of megawatt per hour and you lost all your consumers, what choice do you have?
Shut off.
You cannot shut off. You have a huge stream of water. It's like, this is my favorite thing, like to the hostess note. You have 40 tons of water. You cannot shut off. If you shut off, you just, like, I don't know, crush all the building there. Like, there will be no plant. So the only way here is to drop water. But what happened when you like dropping water from that thing? You actually float all the village or everything, and you have like no other choice, because it will be float in any case. If you just like shut down and close the gates, it will just like completely, yes, broke everything. So you have to float everywhere. So from the penetration testing perspective, what was the attack like target on? Was it target on the consumer, or was it target on the power generation, or was it target on all the humanity, people who actually lives in the village? I actually have no idea. It was a graduate guy. But he somehow managed to cause a lot of consequences by just like cutting the power source and then cutting the consumers. There was a lot of news in Russia, like, oh wow, graduate able to hack, and they actually float the whole village by just like using his laptop and no specific software out there. He was just like playing, doing something he read in a Stack Overflow. It's not a joke. So for sure, there's systems that's supposed to calibrate itself. Like if one part of a system will fall, another part of a system will understand the fault and actually behave appropriately to mitigate the risks. But there's still some, like, all those automation like DCS, distributed control system, is kind of huge tree of a state machine, and there's a huge states, and the machine knows like from which state to which state it can jump, like how to jump and what to do if it actually get to the state it's not supposed to be. But there's still some unexpected states of that machine that not pre-programmed, not the state the engineer not thinking about. And for smart grids, I'm pretty sure you're aware of that concept. Can you give me some idea about concept of attack on a smart grid that use some unexpected state of the system? Like if you're penetrating the smart grid for profit and you have to cause some damage, or kind of, can you imagine any kind of attack?
If you take control over the smart grid, you can stop the circuit breakers are open to make a blackout.
Yeah, but it's a smart grid. There's millions of elements out there, and if you control one, it actually, nothing will happen. In the replay. Or maybe like amplification replay attack, when you just like replay to all the parties, when you broadcasting the message to all the elements in the network. Kind of. What about spoofing? Like the simple spoofing. When you try to pursue all the other elements of the power grid to believe that this particular or those particular elements are, I don't know, closed or broken. The all other elements will behave in a way, if those are really broken, and try to manage to pass the power across them or somehow bypassing them. But those elements are actually not broken. You're just spoofing the state of those elements. There's a kind of, do you know the concept of fault tree? So it's like in a system automation, it's like major concept. When you're building some automation system, you have to have a fault tree, like in case if this element will fault, the system will go this way in case of this. So in that fault tree, you have to actually think about some impossible things that not possible by nature, but possible by hacker, because those guys are able to cause fault on the hundreds of elements in the same way, in the same time. I mean, like, most of the engineer thinks like, okay, we have steel milling manufacturing. We have 2 lines or maybe 3 lines of milling steel, and there's like a huge process because from beginning there's like raw resources. You have to burn it. You have to mill the steel. You have to roll it, and it's like align it step-by-step things. And if you have one line broken, okay, you have like other 2 lines, and you have to reroute all the resource and remanage all the, but it's possible. 2 lines broken, it's like quite not very possible from the engineering perspective, and like all lines broken, it's like something that not supposed to happen ever, because there's like 3 of them. But from the penetration testing perspective, if you have access to the network, you have access to the systems that actually control those physical lines. And those are identical because they were built by some same company. So we built like 3 lines with the same software, same hardware, and you have an exploit which actually caused the denial of service or some other condition for that line. It costs you nothing to send 3 exploits at the same time. So something that you think it's impossible, actually possible, if you use, I don't know, cycle, for, while, or some kind of. This year I was in Singapore and played as a blue team member of Kaspersky team. Was asked to participate to analyze the network traffic. And there was about 8 red teams. Each have 4 hours to get into the network, to analyze the elements, to try to penetrate, to control, to disrupt, to cause some damage. And we have to like collect all the traffic, analyze it, and identify attacks on the like on a time, like right at the moment. And the setup was water management system that was actually supposed to recycle the water from the university. So like in Singapore, there's a huge University of Technology, and all the master graduates they working on a project that is a part of a university itself, like power grid for university, or water treatment for university, or a smart automation system for a city itself, or like waste recycling for a city. So you're like working for 2 or 3 years, making your master by actually being involved in the real project for real something, not just abstract. And we were working on like analyzing the attacks on the water treatment system. Can you tell me what are the parts? It's actually DCS. So have you any experience with DCS? Okay, so you definitely will easily recognize some parts of DCS from that screen. It was like HMI. And we have no idea of like what's out there except that HMI. And we have a traffic for sure. Just name any part of a process once you see it. So okay, I'll help you a bit. You cannot see the text, it's like too small. But at the left, there's for sure a tank, right? Because it's like a huge and there's something. And there's the 2 pumps. And there's like 3 smaller tanks that are not actually tanks, but something that holds something. And it connected to the pipe. What they are for? Okay, you have no idea what they are for. But there's another tank. So the water from one tank goes to another tank. And something actually emitted from those 3. So there are the chemicals to actually clean the water, like chlor or other stuff. So okay, once the water pumped from one tank to another and fill it with the chlor, you can see the small thing on the pipe. It's actually a mixer. It's a mechanical mixer that will mix the water with all the chemicals. Then it goes to another tank, and actually that white thing out there. Oh yeah, sure, thanks. Okay, so this is the chemicals. This is the physical mixer. This is the filter with do you know osmos system? Oh yeah, so it's like back osmos. And then it goes to This is a UF machine that actually clean the water with the UF rays. And as you can see, there's a back loop to clean the filter. To clean the filter, the water gets from here and back to the filter to clean it up. So there's like 2 ways for water. One goes through the filters to the tanks and back to reservoir. And the other goes to the filter and clean it. So if you look to the traffic, to the IP addresses, to the names of the system, like if you spend, I don't know, 3 hours analyzing the system itself, you will figure out finally that there is a kind of 9 systems, and each controlled by particular controllers and have a particular HMI. We have no access to the clean zone. We have only HMI and the traffic. But the like red team have access to the clean zone. They can see what actually happening there and here, and be able to match the parameters in the traffic with parameters on the HMI in the clean room, and so on and so forth. So once you figure out it's DCS, and actually each of those squares perform a logic, and that logic is distributed. And each of those controllers knows about what parameters are like how much water previous square pump through, and it knows how much it has to pump out, and it knows the states of all those valves and the pumps. So having all those knowledge inside the program that control each square, you have to figure out what the engineer is forgot to think about, or where there's a gap or some state that's not supposed to ever happen. And we figure out if we actually start, not actually we, but we, from a defense side, we figure out the first thing the attacker will do is spoofing. So we start looking specifically for spoofing events of valve being like closed while it actually opened, when otherwise, or other things. And we very fast figure out the people trying to spoof the level of the tank. So the teams try to spoof that the level of the tank is very low. So the pump will like run and try to pump a lot of water out there, but the water is like on top of it. But because people just spoofing the state, it will like broke the tank itself, it will broke all the pipes, it will broke the valves or pumps because it's too much of water. Then they try to spoof the information about how much chemicals put into the water. So they like they intercept communication between the elements by like simple IRP spoofing, and they change the information about the chemicals, like there's no chemicals in the water. And so the dosers of the chemicals start to push a lot of chlor to the water, so you can imagine how much toxic the water become at the end of the challenge. So thinking about like element by element, you can see if you turn the valve here and run the pump there, you actually could cause a condition when the safety system will not work. Are you aware of safety system? Okay, so here's the case: a power plant, nuclear power plant, and it's like totally secured. And in the worst case, the safety system will just like shut down the power plant. Is it kind of a successful attack or not, in your opinion?
To shut down the power plant?
Yes. Yes, actually it's a successful attack because you have to spend at least 1 day or maybe 2 days to run the nuclear power plant back to the normal. And the owners of the power plant will lose a lot of money because they are not producing the energy, and they have all that maintenance cycle, like shut down, turn on. We spoke with the people from those companies. It's like, no, it's normal like behavior. We asked them, how many times you like shut down your power plant just like because of something? They said like, oh, it's only a few times in like 5 years just for maintenance. So imagine a few times a month. Say, oh, it's a huge threat for us. That's where you can use the safety system to do something that you are not allowed to or have no control over. And the same with the technological process. You're actually pushing all that logic to do the work they're supposed to do, but in a way or in a state they are not aware of or not supposed to actually perform, like pumping when the valve is closed, but you actually broadcasting on a net that's open. Okay, so this is the end of boring part. Are you ever heard the fuzzing? Okay, so you're from security side. Have you ever tried to fuzz something?
On the ICS infrastructure?
If in IT it's okay.
IT is the normal process of penetration testing.
Yes, and actually a part of a safe development lifecycle, secure development lifecycle. So we have experience in the fuzzing. I guess you will have at least some fun. So I guess you all know that the fuzzing is about finding the input input of the data, putting the data in that input and looking for a program if it will broken or not. And if it broken in some way, you have to figure out why. You have to trace the data, bless you. You have to trace the data that you pass to see how it actually broke the logic inside the program, where it actually, how it was processed, and then figure out if there's any condition that you can use to exploit, to get some, I don't know, access to memory, to control some address of function calls, to being able to execute something, or maybe to modify something. And as a part of our training that we actually ran many times, the training on penetration testing, it took 5 days. There's a part that we teach people how to make a fuzzing. So we give them a virtual machine and it runs some software for industrial control system, like a real one. They open the TCP view. Do you know TCP view? So, okay, you see all the TCP connection, you see all the services that are listening on different ports. You see some particular of them and try to establish communication with them, but you have no luck because all the connection you try to make, they just actually closing the TCP session without the reason. But the reason is you are not aware of a protocol. You're not aware of what the function is expected. And there's two ways. One way, you open the binary code, you found the place where there's like a code responsible for handling a socket, like send, receive, and you see all the connection to that function. You see, look for all the logic that actually process the data that you're supposed to send and see what it expects. And then you send the data and debug all that code. On the other hand, if you have a semi-working environment where some service communicating with some other service on the protocol or a TCP, UDP port you're interested in, you can actually intercept the traffic, look for all those headers, fields. You can actually dissect it and try to figure out where's a, like, have you ever designed the network protocol? Like you have a client server, you have to...
Coding or design as a,
no, like
great neuron.
Like in your education, you have to write the client and the server that actually exchange some kind of message, and that message actually part of a protocol. Have you ever designed your own new protocol for communication? No? Never? Okay, I'm pretty sure you've seen a lot of other protocols designed by someone else. So can you tell me what are like major part of all protocols, the fields?
The starting of stream and end of stream or something.
No. I mean, if you have a packet, what fields are there?
You mean header and the body?
Huh? What? Header, for sure, and like data. What's in the header?
You mean the well-known protocols in the IP, TCP IP?
Yeah, TCP IP or Ethernet.
There are already also fixed in the RFC document. RFC. So
Yes. But I mean, if you seen the TCP packet, and it's like a bunch of bytes.
Source, destination, address.
Yeah, there should be some source, destination, some services in the header. Flags. There should be a length of the message.
it depends on the protocol, I would say.
Yes, for sure. But there still have some header that actually define some function. and a payload, header and a payload. That's actually a pretty simple concept. So once you identify the header and the payload, you will be able to actually make any diff between those in a series of pockets. You can see how the header changing, why it's changing, what fields are changing, what fields are for data types, because when you send the data from one side to another side, there's only like two ways. You for sure know what type of data is, or if there's like a variety of data, you have to mark it as like string, integer, double, unsigned int, or something to be treated by other side of the system correctly. And we'll teach people how to intercept the traffic, analyze the traffic, how to figure out where the fields are. And then actually we showing them how easily to create the client for some service, how to create the fake TCP pocket that actually comply with some structure that they seen in a Wireshark, and how to randomize the generation of a payload or some fields in the header to make a lot of connection from your fake client to that server on the same host, I guess, and eventually crash the server side and then collect the dump of a memory, analyze it in the debugger like WinDebugger, WinDBG, or even there tune up the payload to being able to control particular address of return. And that's actually what is fuzzing for. And when you ask me, how can I cause the domino effect in the controller? I have no access to there. They like controller not accepting any commands without getting the password from me. I'll tell you, just like start fuzzing on the client side or on the server side, and before that you for sure have to intercept the traffic, because many times you see the system are designed in a particular strange way. One day we researched for security system for buildings. So there's like a huge company that developed a lot of security systems that have to allow you to enter the door if you know the PIN, if you have a I don't know, a pass, like if you have a like fingerprint or kind of. And we analyze how those locks on the door communicate with some engineering or SCADA system or HMI. And we figure out that if you are like an engineer and you try to connect to the lock, it actually allows you to get all the information, allows it to control it. And as an engineer, you have to protect that lock from another evil engineer to connect. And you set the password to that lock. And every time you trying to connect to the small controller in a lock, it asks you for a password. But from a network perspective, what actually happened is that the lock sent you as an engineer the password, and your engineering software interpreted in a way like, okay, I got the true password from a lock. I have to ask my user about the password and then match it. And then if they match, the engineering software tell the lock like, okay, I checked, he's like allowed to connect. So it's like a client-side verification is bad, but it's still happening in things that are supposed to control the doors in a building, I don't know, in the banks, in the other. Yeah, like sorting the password is like here and there. You just like see some strange string. When you change the password, you see the strange string consisting of strange symbols, and you figure out it's actually the XOR of 1 byte. Okay, so people like we've seen a lot of very strange vulnerabilities out there, and once you able to analyze the network traffic, analyze the source code, try to fuzz it, you'll definitely find a lot of mistakes the people do. And once you found the mistakes and you're able to manipulate the memory or state, you're able to create all that chain of root and cause to get the system into a state it's not supposed to be, and the state is unable to handle. I guess that's it. If you have any question, you have a chance to ask me here, or I know we have a party somewhere in the pub, so if you're strong enough, you can wait until we drink few glass of some nice drinks. Yeah, sure.
Do you perform also penetration testing for real installations, like for real stuff, not only for CTS, but?
Yes, sure.
And what are your, let's say, observations regarding the, let's say, the common mistakes or common problems that are in such real-life installations?
Are you asking me about like the life from a physical perspective or a technical perspective?
Result perspective. When you turn off the power plants.
I mean, what are the common problems in such installations from your experience?
Okay, from a physical side, there's.
Not from the impact.
Yeah, sure. From a physical side, there almost like no security practice at all. So like no locks on the doors, or if they are, the doors are mostly open because people have to go here and there. If we talk about high voltage bay relay, it is not. There's a key in the high voltage bay relay that actually turn to two states. One state, it is allowed to reprogram from remote. If you turn the key, it's like a blocked. It will like not being able. You will not be able to control it from remote. And most of the time, the key is turned to the remote control. So once you're in a network, you can find the relay and remote control the relay. The same with manufacturing. There is have you ever heard about triconics or trices? So the same thing with the key. There's like on, off, and debug. And debug actually is your phone allowed to completely mess with all that stuff. I heard a story about some Chinese antivirus software. If you plug your Android phone to your computer where that software running, it will actually see if you have ADB. ADB, it's a debugger for Android. And if you actually allow the ADB, it will connect through the debugger and install that software to your phone. It's not a joke, it's real true. The same with all those like power systems, manufacturing. Those people are used to live in that environment and they are used to live it like as simple as they can. The second, most common problem is that if you have a manufacturing or power plant with many systems there, nobody will ever divide it in a subnets. So once you're there, you see everything. One of our colleagues were penetrating the beer brewery company. They asked for penetration testing, and in the very first day, they have like a free day to connect with all the members who should know, who's supposed to know about the testing, and they got to like local cafeteria of that huge brewery, and they have like a beer in the cafeteria for free. I guess it was alcohol free or kind of, but it's still like brewery and cafeteria, and you have a beer for free with your mashed potato and some beef. And while they're having lunch there at the very first day, they use like a phone to get some connection with outside world. They found the Wi-Fi, and one of those guys like say, "Oh wow, Wi-Fi! It's have a strange name and it's open. Can I like scan the network and see what is there?" And actually, he found out this Wi-Fi gives you access to the network that connects seven different breweries across the EU. Yeah, you know, like you're in the cafeteria eating your mashed potato and actually can connect to one of those, like in Germany, I don't know, in the Prague, in the some like UK brewery. So those are like a main, like no physical security, no responsibility for every temporary decision. I actually stay for a long time, so they have no responsibility and no like basic security things in the field. Any other questions?
How about gaining access to the network, to the SCADA side network, not from the managing perspective for the syncing the traffic, as you showed the exchange between the...
Okay, so there's a many ways into the ICS. Like from classic way, you have to start from internet, pen test the corporate network, and in the corporate network you have to find the computer of engineer or a manager have access to industrial control system. As you know, the engineers who actually develop the software for SCADA, because like a Siemens provide you a SCADA, but it's not complete SCADA, it's a framework, and you use the framework to build your particular SCADA for your particular technological process or your particular HMIs, and all other vendors the same. So there's definitely the engineer, developer who have access to corporate network and to industrial network. Through the bypassing the firewalls, bypassing any rules, you have access through the RDP, VPN, or VNC, Radmin, any of those. Once you found the computer of that engineer, you actually have to penetrate his machine. But if there's no way to penetrate his machine directly, you have to be much clever and find if there's any other machine he actually log it in, or maybe if there's any other machine with other administrator or network administrator. So once you found the weakest machine where it's probably some administrator connected to, and getting access to it, you have to read the memory. Once you have access to memory, you can see if there's any cache of the hashes, LM hashes from Windows. So getting access.
Have you ever seen the properly sealed SCADA network via data diodes or so on?
Actually, data diodes are not, they are on the paper, they are physically, but engineers in the company or engineers from a vendor or engineers from integrator have access like via RDP, VNC to support the system, because yes, because like every factory I visited, I heard the same story and I actually seen the same stuff. There are people out there who understood how it works now, but they have no idea how it works like in a global scale. And if something goes wrong, they like have an instruction to took the phone and phone to integrator or to vendor and say like, we have a problems, Houston, and the Houston actually connect from remote interfaces through the VPN, bypassing all the firewalls to the SCADA system with the administration access, because they need to get all the information about, and actually they're fixing everything. Once on the security audit, we've seen some strange internet connection outside from a SCADA system outside to the internet. We asked all the engineers, all the security members, like, have you have idea what those IP addresses are? They say like, no, we have no idea. And we actually tell them that if they have no idea, they have to shut down those like connections. And once they shut down those connections, what do you think happened in the next 3 hours? The vendor actually called to the customer like, hey, we lost the connection. He said like, which connection? Like, we have a connection from your plant, so we managed your plant. Like, what? I didn't ever heard of this, like for the first time. Like, what are you talking about? He said like, oh, actually for the last 5 years, we saved you from few accidents. So the vendors are very responsible people. They spending free time to managing the customers, so the customers are happy and not experience any problems. On the other side, if you have like completely no way, everything in a data diets, you still have a you still have a Wi-Fi. You still have a Wi-Fi. Wi-Fi, it's like you have to have a parabolic antenna to see if there's any Wi-Fi out there, because all the things that are remote, you have no wire long enough to connect them. So you connect them via Wi-Fi or via 3G. 3G is another vector. If you have like a pipe in a field, and there's like a controller, and you have to measure the amount of, I don't know, water, oil, or gas passing through, and you have to control the valve to keep the pressure at the same level at the pipe. The only way to connect that piece of a pipe to the main network is to using the SIM card. And the network provider tells you, okay, I give you a SIM card to get the internet, and you're like behind the NAT, you like have no public IP address, like it's only virtual and so on. Well, it's a bullshit. Actually, if you bought a SIM card, connect it to your tablet and look for your IP address, it will definitely be some IP address from a pool. It will change from time. Like today one, tomorrow another IP address, but there's still a pool. So pool of, I don't know, 10,000 IP addresses. And if you know the pools, what the diapason, I mean, like what the beginning or the end of the pool, if you know them, you can scan them, and actually you will find out a lot of ISIS equipment out there. 3 years ago in Miami, one of my friends, Alexander Bolshev, shows the presentation about ridiculous way to penetrate the IT management system. He actually found there was sensors in a field on a pipe, and those sensors was able to communicate via protocol. Let me just remind. Just forgot. So the protocol the sensor used to communicate with the RTU is like 420 milliampere. Just forgot the name of the protocol. And you can imagine 420 milliamperes. You have to encode all your data into the signal and actually pass it to the remote telemetry unit. HART protocol. Have you ever used the HART protocol? Yes. It's electrical. Yes. It's a current 4 to 20 milliamperes. And actually he used the specific hardware to get the signal and decode the signal. And what do you think actually the sensor was encoding into current? It was XML. It sounds really funny, but it was XML encoded in the current. And moreover, that XML supposed to pass to the MES system that actually manage the manufacturing process. And straight from a MES, it goes to a ERP system and goes to a SAP. And it goes like in the same way it actually gets from a sensor. So what my friend Alexander Bolshev did, he actually used the Hall sensor. Have you heard about Hall sensor? It's the way to mess with a magnetic field. So you can actually connect directly to the sensor, or you can actually mess up with a magnetic field to change the data on a wire. So he actually put the malicious script into that XML. And that script was actually executed at the SAP, at the top layer of a corporate environment. So that's the way he actually get access to the top corporate management system from a field by using like just 2 needles.
Okay, but you have to dig the pipe and
No. It's on the filter. Like if you go outside or on the street, you will see the boxes. There's like valves and the meters about like how much water, electricity was like consumed by that particular building or some other things. So I guess I'm pretty sure probably not, but the same things you can see with the display that's actually doing something. So you can actually take them off. On the desk, right. So those things that actually control something, if they're connected to the building automation system. So there's some administrator watching, like we have a light here, we have a projector here, like everything is nice. Actually, there's supposed to be some camera here. And so once you have like feedback, you can put some data in, not just like in the data diode, yes? You can manipulate. Once you have able to manipulate, you can fuzz. Once you can fuzz, you will find the bug. Once you found the bug, you will actually get access. So, any other question? Oh yeah.
One question. How to perform black box penetration testing in OT environment in safe and secure way? You said that you perform black box in OT environment.
Yes, there's only one way to perform the penetration testing of ICS environment in a safe way. You have to have copy of that ICS environment in form of a small lab, because you have no way to make it safe pen test in like production, not crashing something. Actually, on the real projects, when you like supposed to I don't know, hack the Windows computer that run SCADA system, and you for sure know the exploit, you completely sure it will work, you will get access, nothing get crashed. You have to call the engineer, like, hello, I'm ready to run the exploit. Like, are you ready to reboot the SCADA system in case I'm like not so I don't know good in developing the exploits? Like, okay. So you just like doing that. Say, if you need to black box in the safe way, you have to build a small lab in the same way, like controller, some small process, and then you can actually crush it as much or as hard as you could, and then you can reboot everything and like reestablish all the connections and start from all over.
Okay, so related question actually. So how you manage risks in real life penetration testing for real installations if you do such? Because you mentioned that you do it.
Yes.
So how you manage this risk connected with breaking something and the process will break, and then you will have to just throw away all your production of the client. So.
No, we're like not we're not rocks. We are a company who actually getting money for that service. So first of all, when discussing the scope with the customer, you have to discuss this, like how deep should you go. You have to discuss what should you do and what should you not. You have to agree on like the time frame when you can do something. You have to agree on the emergency responders from the customer side who will actually do something if something goes wrong. And you have to agree on the what is the agreement protocol. Like, you found the machine and you think it is some kind of engineering system, and you think, okay, so my goal is to get administrative access on that particular machine, and then my like first penetration testing goal will be accomplished. But the protocol that you agree with the customer is that you have to call to the engineer, say, okay, I have the IP, I have a computer with IP address that I'm supposed to attack, and so on and so forth. It says like, yes, you can attack this machine, nothing bad will happen. We have another machine performing the same function. So you have to agree on the protocol and how to agree on like particular attack step.
Okay, but I'm curious how often actually you attacker
Never.
can scan, for instance, controllers in OT network, in real OT network. Is it actually, which is something which you do in actual penetration testing, or this is like a field which you are not touching because it's too dangerous for invoking something?
We actually know what can we do and what can we not do, what should not we do, what shouldn't we do, because we have a lot of equipment in our lab and we actually test all that equipment with different strategies of scanning, and we see some particular controllers will freeze if you like send the TCP SYN, it will answer you TCP SYN ACK. If you're not sending it TCP RST, if you're not closing the TCP session, it will freeze. It will not accept any other connections. So,
it's quite common.
so for major equipment, we know what to do, what possible, what's like safe way to scan. For equipment that we are not aware of, we are actually listening the traffic and learning everything from the traffic because it's the most safe way to.
Okay, the question is, so what are the, let's say, the passive ways to let's say, to find out what kind of equipment is in the network? Because sometimes you don't know what is in the network, yes?
Yes, sure. So first of all, you need to listen for broadcast. Then you have to identify the Windows machines. Most of the time, if you actually crash the SCADA system, nothing bad will happen because the engine. Yes. So you have to separate the controllers from the Windows computers. If you crash the operator machine, HMI, Historian, or SCADA, most of the time nothing bad will happen because the controller will perform the same way. And once you figure out what are those Windows machines, you can use the ARP spoofing or like hacking those machines to get the access to the traffic they communicate with the controller. And if you figure out it's like what you're looking for, so that's nice. Most of the time the customer asks us to get root access to the SCADA, engineering machine, or any other. Very rare case when the customer asks us to, can you actually broke my technological process? Can you actually like blow everything out? We say like, yeah, for sure, but you have to have a small lab. Yeah, you have to have a small lab, so the blow will be like very small on the table, or maybe virtually in Unity. You know, in Germany, there's a lot of companies, in the US for sure, companies that making the digital clones of existing factories and production, and they can play with all those things like blowing, crushing, I don't know, anything, because they have like digital copy of real production in their virtual environment.
They play on this digital copy, yes?
Yes.
The question is how to what extent it simulates actually all problems of this, let's say, equipment.
Well, you have to have a nice vulnerability management, because all the problems are from vulnerabilities. It's like on the first place, and the second is not tightening the control. If you have like flat network, it doesn't matter if you have vulnerability or not. It's like flat network, everyone can command. If you like restricting the access, the second step is like fixing or closing all vulnerabilities, so nobody be able to get access, even like exploiting something. And actually, I'm pretty sure you're not seen, but we have a report on vulnerability for VNC. There's a tons of vulnerabilities since 1999, when the vulnerability was, when the VNC was forked into many like tight VNC, real VNC, that VNC, here VNC, and they actually copied the old bugs. It was like in the very first versions, and they're all vulnerable to that. Hopefully, most of the producers fix the bug, but some says like, oh, it's like too old product. We're running version 2. We're not going to fix that 1 point something. But that 1 point something actually installed in 30% of all like industrial computers. So.
And one more question, sorry about.
Yeah, sure.
And because you're working in CERT, so
We will move to the bar.
I think in Koszyki will be, a little bit harder to discuss. So last question, okay? Last question. Sorry about that. From CERT perspective, what kind of attacks you observe as a CERT team for attacks to OT networks and OT systems? Do you observe? Do you have customers which you actually are monitoring the infrastructure for them or not? So
As a company, yes, we have a Kaspersky managed protection KMP.
What kind of attacks you see for OT networks?
To tell you the truth, the only way to see the whole attack chain, to understood all the logic and all the like root and cause, is not just like you monitoring the attack from somewhere, because once you see the reason, the sign of attack, you just like completely block it. So you have no idea about like what attack is supposed to be. But performing the incident response.
Okay.
So performing the incident response, you actually have an incident that happened in the past, and you have to figure out all the steps it gets. And yes, we performed a lot of incident response, and a few recent of those were the customer just called us through the many connections, like, oh, we have like serious situation here. We having all the SCADA and operator systems having like a blue screen, and we are unable to use them to control the process. We actually reinstall everything. We replace the computers, but it's still like running into a blue screen. So like, can you help us? We actually get there and figure out there was a problem not with the computers itself, but there was some other printer or some kind of some old computer out there. And it was infected with some very rare version of WannaCry. So the WannaCry, like the main binary, consists of two parts. One part was supposed to spread by using vulnerability, and another like part archive inside the executable was supposed to hold all the modules for encryption. That ransom message and all that stuff. And that archive was broken, was corrupted. So the malware keeps spreading, but was not able to encrypt the files. And trying to figure out like what's actually happening, we found out those computers getting the blue screen. They was all running like Windows XP, SP2, that are not compatible with the exploit developed by WannaCry. So it's not penetrate those computers, but just cause them to denial of service every time, like in a cycle. We're trying to figure out how the WannaCry get into the ICS. Have you any idea how the WannaCry get into ICS?
Someone bring them on the machine.
How?
How? Some support guy. That's usually scenario.
But I think that there could be like a workstation connected to the internet and just some.
No, there was no substation connected to internet. Yes, that actually was true. There was not the support, but some guy with a laptop who like recently plugged his laptop to the corporate environment, and because of that corrupted sample. He actually got infected, but have no encryption performed, no ransomware screen. He was just like infected. And he bring his laptop to the production environment of his customer to fix something, and definitely infect some computer. So we have to write a lot of papers about describing all the things and.
Okay, but something more fancy than just pure simple ransomware, because ransomware is quite common in ICS.
No, you asked me about the way the malware actually brings into the network. It brings on the laptops of engineers who work for vendors, for integrators. so the engineers are like most weak point because they have access to internet, they have access to corporate network, to many different corporate networks. They bringing laptops to the many industrial facilities, and they have all sort of malware on their computers, and they actually like seeding it, like, you know, here and there, like malware everywhere. On the other way, there's cyber criminals who looks for remote like RDP. Do you know joke about RDP? Like how? What? No. I mean, can you tell what the RDP means?
Remote procedure
R
desktop
protocol, remote desktop protocol. So yeah, there's like a rumor that RDP is a ransomware deployment protocol. Because people actually brute force the login and password, gets into the machine, looks where there are servers with SQL servers, with the databases, shut it down and actually encrypt everything. There's a lot of spyware that actually knows all your passwords from your browser, from your SSH, from your keystrokes, from like video they record, and all that information get to the command and control service of threat actors. And even if there's like, I don't know, some people who are not supposed to hack ICS, but they just like collect a lot of information about your factory, what do you think they're supposed to do with that? They will sell it. Like for anyone, for $4. They will sell all it for $1 or maybe $2 for anyone who interested. And the guy who actually purchased those login and password, he can get from a legitimate through the VPN or through the RDP from somewhere using your credentials to get access to your. Do you guys playing on the stock market? Anyone?
Forex.
No. I mean the legal stock market. Okay, I mean, from that perspective, if you have a lot of internal information from company that producing, I don't know, steel or petrol or like something, you could actually like making a lot of things to do with the stock prices, right? So there's a lot of motivation out there.
Not in the SCADA perspective, but in office perspective.
No, from office you will see Excel, but from a SCADA perspective you can actually change something. I guess.
Which are producing the.
So asking about motivation, yeah, there's a lot of way to for cyber criminals to get, but all the APT attacks, they like for decades they collecting the information before they were discovered, and they collect information not because they, I don't know, need your login and password to connect to PLC to blow your factory, but because they try to learn everything about like what's actually happening. So when it gets to do something really, actually those guys will know everything better than the engineer. They will know everything about.
Protect that. That's why some customers are really afraid to transfer data to cloud, from production to cloud.
That's true, but like in the cloud, there's many customers, and that makes the cloud interesting target for threat actors. The same with car sharing. They have a car sharing here in the. So we actually recently we test the car sharing system and the service and so on, and figure out there's a lot of vulnerabilities out there. So anyone can actually like get a car and like mess with it. The same with the digital private certificates for not for a person but for companies. Like if a company or a person, like you can use not your like physical signature but your digital signature, and those digital signature stored in the cloud. So once someone get access to that cloud, he can use the digital signature to, I don't know, give himself a flat or a house. and you have nothing to do with it. So the cloud is actually supposed to protect, but yes.
Do you know from your experience situation when somebody, attacker, changed firmware on controller or on code of control system, or changed functionality of program inside the controller?
Yes, many times.
Because from my side, it's obvious that when you have access to OT network, most of protocols are open. You don't have to fuzzing or check via Wireshark. You can open documentation for protocol and you have full information about functions, about the data structures, and for example, if you have access to, for example, to OPC server,
Okay.
old systems use OPC server without any security. You can have full access on every controllers in the network.
Yes, actually, that's the problem with OPC, and we also have a.
Of course, it's changing.
Yes, we have a research on the OPC. It's just there's a lot of bugs in implementation. OPC it's like specification. There's the main implementations, and there's a lot of bugs in those implementations. What about changing the firmware or program on top of a firmware? Yes, sure. There's a lot of engineers who works here and there, and they, trying to find a way how to make their work more profitable by stealing something from, I don't know, from a gas station. Those people actually were in like 50 years ago when there was no actually the industrial control system. They hack the physical systems. I like heard a lot of stories. I will told you at the bar. But for now we know there's like Triconics. There was some third actor who actually get into the manufacturing system and rewrite the firmware of a safety system. And once you rewrite the firmware of a controller, there is no way to know if it's infected or not, because once you try to ask him, are you infected? And the malware says you look, no, it's not infected. Like, no way to know. On the other hand, the people that try to mess with something in terms of economical things, like trying to, I don't know, steal something from employer, they're changing the parameters of the program to get something like here and there. Imagine you're an engineer at the mining and you're actually responsible for a conveyor that gets the old gold or some other very valuable stones. So we can actually do it like a bit more, I don't know, not stable. So something will just like broke out, and you will get at the end of your like work and took a stone like full of like gold and like go out. So that's the main reason for the people. There was other. It was called blastworm. Blastworm, I guess. That was a concept presented at the DEF CON a few years ago. The people shows how to write a worm. Or the worm was written on top of a firmware, and it was able to spread through the Siemens 400, S7400. So one from another. Somewhere there was a bug like the controller is not allowed to rewrite the program if you're not having access to it or something, but you still have a way to rewrite that policy, and then you're rewriting the program. So there are many stories. I will give you it. Don't be at the bar.
Okay, we should continue in bar, but last word is.
Oh, sorry. Can you?
Kasperskiego Polska. Po pierwsze chciałbym podziękować Kiryłowi za przybycie i Państwu za udział w tym szkoleniu. Proszę się nie bać, to nie jest żaden mały.
Jak mamy to wiedzieć?
They are asking how can be sure that it's not a malware behind this. I was checking. Ja sprawdzałem to osobiście, więc musicie mi uwierzyć. Natomiast prośba, to jest krótka ankieta na temat tego wykładu. Chcielibyśmy uzyskać jakąś informację zwrotną od Państwa, czy dowiedzieliście się tego, co chcieliście się dowiedzieć. Po drugie, to, co tutaj mówił Kirill, to jest częścią szkoleń, które my jako Kaspersky organizujemy. Chciałbym zaprosić, gdybyście Państwo mieli dla siebie, dla Waszych klientów, przeprowadzić takie szkolenia. Mamy w ofercie szkolenia ICS Pen Testing for Professionals, yeah, the trainings, yeah. ICS Digital Forensics for Professionals. Zapraszamy też do skorzystania z innych usług, takich jak organizowanie Capture the Flag, yes?
Yes, vulnerability research.
Yes. Zapraszamy też, organizujemy co roku już od 7 lat taką konferencję poświęconą właśnie tym zagadnieniom. Zapraszamy specjalistów z ponad 20 krajów zajmujących się tematyką bezpieczeństwa ICS i Kaspersky Industrial Cyber Security Conference. Ona się odbywa co roku w Soczi. Myślę, że to jest tematyka też dość interesująca, żeby ktoś chciał, to zapraszamy. When do we plan to have a next industrial cybersecurity conference?
It's next year, end of September, beginning of October, or maybe middle of October.
Na pewno informacja na ten temat będzie się pojawiała.
Gdzie jest to konferencja?
Is this conference in English or it's in Russian?
Yes, it's in English. It's an international one.
Z tego co się orientuję, zaproszeni są specjaliści z ponad 20 krajów, przynajmniej tak było na ostatniej konferencji w 2020 roku. Także też tutaj zapraszam. Gdyby były jakieś pytania, idziemy, myślę, tak słyszałem, że jest taka konwencja, idziemy do baru, więc myślę, że też będzie okazja jeszcze porozmawiać, może w mniej oficjalny sposób. Proszę nie krępować, pytać. Kirill idzie z nami, więc zapraszamy. Jesteśmy tutaj dostępni. Proszę? I same prawdziwe historie, tak, dokładnie. They are expecting some real stories in the bar.
Oh yeah, that's true. Hard stories.
Dziękuję bardzo. Jeszcze raz proszę, jeżeli jest taka możliwość, dać nam feedback.